Now we've done some adding and subtracting polynomials. We are going to move on to multiplying and dividing. So if you remember, a monomial is a number or variable or a product of number and variables. So something like 3 or 3xy. Monomials can only be added or subtracted if they are like terms. So 3xy plus 6xy would be 9xy. We also know our exponent rules, that if we are multiplying powers with the same base, we are going to add the exponents. If we are dividing powers with the same base, we're going to subtract the exponents. And if we're raising a power to an exponent, we are going to multiply the two exponents. So now we can actually go ahead and apply those to some more complicated situations. So here we have x to the exponent 4 times x to the exponent 3. We are multiplying powers with the same base, so I can add the exponents. Example B, again, I'm multiplying powers that have the same base, which is the base of y. I am going to first multiply the numbers that are in front. Then I'm going to keep the base the same and add the exponents. Example C is even more complicated. I've got multiple variables and numbers. So the first thing I'm going to do is multiply the variables together, or multiply the numbers. So minus 2 times 5 is minus 10. The next thing I'm going to do is multiply the a's together. So a cubed times a to the exponent 1. I'm multiplying, so I'm going to add the exponents. Next, I'm going to do the b's. So I've got b squared times b to the 1. I'm going to add the exponents. C is all by itself, but still important. So I'm going to add that on to the end. My next row of examples, I'm going to look at dividing. So here I'm dividing two powers that have the same base. I'm going to subtract the exponents. Here, now I'm dividing powers with the same base, and I have a numerical coefficient. So the first thing I'm going to do is divide those numerical coefficients, which will give me 7. Then I'm going to look at the exponents. Y to the 8 divided by y to the 6 is y to the 2, found by subtracting the exponents. Here I have another way of expressing divide using a fraction line, and I'm going to approach the same way. So the first thing I'm going to do is divide those numerical coefficients to give me 5. The next thing I'm going to do is I'm going to look at the m's. I've got m to the 7 over m to the 1. Subtracting the exponents gives me m to the 6. And then I've got n to the 3 over n to the 3. Subtracting those gives me n to the 0, which is actually just equal to 1. So I can write my final answer as 5m to the 6. My last row, or my next row, I'm going to be raising a power to an exponent. So remember, I'm going to multiply those exponents together. In example H, I have a number. Now that number is affected by that exponent as well. So the first thing I'm going to do is raise the number to the exponent. 2 to the 5 is 32. And then I'm going to multiply the exponents together to find the new exponent on the y. Same thing in example I. The first thing that I'm going to do is 4 squared. The next thing that I'm going to do is multiply these exponents together. Finally, I have an expression with two variables and one number. So the first thing that I'm going to do is minus 2 cubed, which is minus 8. Then I'm going to apply the 3 to the a and the exponent of 1. So that becomes a cubed. Finally, I'm going to apply to the 3 to the b to the 5, which is going to become b to the 15. A few rules are here to follow. So to multiply terms, you're going to multiply the coefficients, and then for each letter, you're going to keep the base and add the exponents. To divide terms, you're going to divide the coefficients, and then for each letter, keep the base and subtract the exponents. To raise a power to a power or power to an exponent, you're going to raise the coefficient to the power, and then for each letter, keep the base and multiply the exponent. So 2 steps or more, depending on how many variables you have for each expression. Okay. So example 2 here is a collection of operations to give us some practice. So the first one, we are multiplying. So I'm going to multiply my numerical coefficients, and then I'm going to multiply my variables together. Okay. M, N. My next one, I'm dividing. So the first thing I'm going to do is divide my numerical coefficients, and then I'm going to look at my variable and subtract the exponents. My third example, I'm raising a power to an exponent. So the first thing I'm going to do is apply the exponent to the numerical coefficient, and then I'm going to apply the exponent here, and I'm going to multiply those two together. Here, 5y minus 7y. Now I'm subtracting like terms. My variable stays the same, and I'm going to subtract my numerical coefficients. So minus 2y. Example E, I have 6 minus 6m squared minus 11m squared. Those are like terms. M squared stays the same, and I'm going to subtract my numerical coefficients. So minus 17. Example F, I'm dividing. First thing I'm going to do is divide my numerical coefficients, and then I'm going to divide my exponents. Just like above, y squared divided by y squared is y to the 0, which is just 1, so my answer is 6. Example G, the first thing I'm going to do is apply minus 4 cubed, which is going to give me minus 64. Then I'm going to apply the 3 to the a by multiplying those exponents. And then I'm going to apply the 3 to the b, so b to the 9. H, my 3 applies to the negative 1 that is in front, so I get negative 1. And then the 3 also applies to x squared by multiplying the exponents. Here, example I actually have 2 operations here. And according to BEDMAS, the first one that I have to do is the exponent. So I'm going to leave 2xy the same. I'm going to apply the 2 to the minus 4, so I get positive 16. The 2 to the x squared, which gives me x4. 2 to the y cubed, which gives me y to the 6. Now I only have multiplication left, so I'm going to multiply my numerical coefficients together. I'm going to multiply my x's together by adding the exponents. And finally, I'm going to multiply my y's together by adding the exponents, giving me a final answer of 32, x to the 5, y to the 7. My last row, I've got x plus x. These are like terms. I can add them together to get 2x. X times x, I'm going to add the exponents together to give me x squared. X divided by x, I'm going to subtract the exponents, which gives me x to the 0, which I know is just equal to 1.